the given figure, we are showing a sector of OAB, OA and B. This sector of a circle with center O containing angle theta. This is the angle theta, and AB is perpendicular to the radius OA. Or AB is perpendicular to the radius OA, that means it is the 90-degree angle, and makes OP, which is produced at B. This is OP, which is increased at point B, and they intersect at point B. And we have to prove that the parameter of the shaded region is r tan theta plus sec theta plus pi theta on 180 minus 1. So let's see the solution. First, let's find out the length of this arc, which is pi r theta upon 180. And from this one triangle, this OBA triangle, we know tan theta is equal to perpendicular upon base, which is AB upon R. We have got the value of AB, which is r tan theta. We know this value AB, and we also have to find O and B. We also find OB. So OB upon R, that means hypotenuse upon base, which is equal to sec theta. So OB is equal to r sec theta, and now we know that the PB is equal to this PB is equal to this total OB minus this radius, this node OP. We can also write OP. So we can also write OP. OB minus OP, that is radius. So we have got PB value r sec theta minus r. We have known the value this PB, we know this AB, and we know this whole OB also. Okay. So the parameter of this shaded region is AB plus PB plus arc of AP, which is AB is equal to r tan theta, PB is equal to r sec theta minus r, and the AP arc is equal to pi r theta for 180. So when we take arc common, we got the value tan theta sec theta minus 1 plus pi theta upon 180, which is we have